Hey guys, welcome. Yeah, so problem one, part A here. And by the way, problem one appeared on both the AB and BC 27 FRQ. And we're in part A here, which means that we're allowed calculators for the first two problems in the FRQ, which are part A, and then part B is the four last questions where you're not allowed calculators. Anyway, the AB and BC exams in total have like 3 overlapping questions, and this is the first of them on the 2017 exam. Yeah, okay, cool. And what you're given is a table, and what the table tells you is like, suppose you have like, a cone shaped like tank, and it looks like this tank is cone shaped from the information given. So like, the fattest part of the cone or the biggest part of the cone is at the bottom, and like it gets thinner and thinner as you go up, right? So that's basically what you're told here. But about the cross-sectional area. So like, you have a cone and it's getting thinner and thinner as you go up the cone, and you've taken slices of the cone at certain heights, at 0, at 2 feet, and then at 5 feet and at 10 feet. And then you're told the area of those slices or cross-sections. And then you're asked a bunch of questions, of which A says, use a left Riemann sum with this 3 sub-intervals indicated by the data in the problem to approximate the volume of the tank. Indicate units of measure. Now notice that since the slices, like for example 50.3 represent area, then integrating upwards along the height is like gonna estimate volume. It's not gonna be the exact volume of the cone, because you only know discrete values. That is, you only know like the cross-sectional area at like 0 height to height and so on. You don't know continuous values of A of H, but yes, like you could estimate the volume. And as they said, if we use the subinterval suggested, we take 0 to 2, right? So there, delta x in your Riemann sum is 2, and since we're using left Riemann sums, we would use the value on the left end of each interval. So on the interval from 0 to 2, we'd use the value at 0, which is 50.3. So we do 50.3 times 2. And then the next interval is clearly from 2 to 5, and it's of a length 3. That interval, delta x, will have value 3. But we use the value for A of H that is on the left end of the interval, so this time at 2. So we'll have, in addition to 2 times 50.3, we'll have now plus 3 times 14.4 and so on. Now, the rest of the calculation should be pretty obvious, and I'm also not going to, bring up my calculator on or anything like that. I have created already about 10 videos on how to use a TI-89, so I'm not going to explain this calculator part a lot. But yeah, if you use your TI-89 and do the math, this time you don't need to know anything special except for multiplication and addition on the TI-89. Then you get 176.3, yeah? Okay, that's that, and that's part A. Alright, so let's move on to part B. What does part B say? Je ne sais pas. Let's see. I believe that one is this, even though it's labeled D. See? I know my stuff. Alright, my labelings. Anyway, it says, does the approximation in part A overestimate or underestimate the value of the tank? Explain your reasoning. Notice that the equivalent to the x-axis now is the h-axis. So horizontally, we go heights, right? Heights of the tank. So if we drew up axes, so that'd be the horizontal axis for h, and then this vertical axis would be for A of H, and a quick sketch of something that would look like the function A of H, even though we're only given so many values of it, would look something like this. So again, this is A of H and this is H. But yeah, since, as they said, the function A of H is a decreasing function, one visual we could have for it, even though we don't know what it would look like as a continuous function, we know that since it's decreasing, it's going to look something like this, right? And it's decreasing pretty sharply, right? But irregardless, I don't know if that's a word, but whatever. Like, so regardless of whether or not it's decreasing sharply, and I should have had it meet the y-axis, shouldn't I? Okay, so like maybe it started right there. So like, yeah, I'm saying this point right here is like 50.3, right? Anyway, so yeah, if we like have a width of 2 to start, as they have, then like that'll look like that. So this is the width of 2, and then a width of 3 then realistically would look something like that, and then a width of 5 would look something like this, right? Okay, anyway, we don't really care about precision. And you should already know what I'm about to show you, but like if you have a decreasing function, then left Riemann sums overestimate the integral, right? And although I didn't say we're doing an integral, like in part A, what we're doing was the integral. We're estimating the integral of the a of h function, right? Okay, all right. We'll be given it precisely as a continuous function in the next part, but instead of a of h, it's called f of h. But yeah, we'll be able to work with that cross-section area function, where we know everything about it in a second in the next part. But yeah, so you see, like this is the estimate of the integral we found an estimate for in part A, and so clearly like it's an overestimate because it, like, yeah, in the first interval it overestimates like by this portion, you get it, and then by this portion in the second interval, and by that portion in the third interval. So yeah, like, yeah, I just wanted to make it abundantly clear for some students. I know a lot of you probably are like, dude, we didn't need all this. All right, okay, cool. So part C then, and part C says what? Je ne sais pas. Let's see. Part C must be this. Yes. Oh yeah, and I already told you a little bit about this part, right? I told you that we were going to be able to know a of h more precisely. And so this time we don't have to do Riemann sums. We could just do the integral to find the volume, right? Based on this model, find the volume of the tank. It's pretty obvious what we're going to do, right? What we're going to do is write the integral from 0 to 10 of, and then it's going to be f of h dh. And since on my calculator, I'd prefer to write f of x dx, I'm going to pretend like h is x and then do this. And the rest of the work I put in the TI-89. Like I said, I have videos about the TI-89 and how to use it for things like integrate and so on. So like I'm going to not show you a lot of the details of what I did on the TI-89 because there are already videos about it that I made, so you can watch those videos. I'll link some of those videos below these ones. But yeah, here's what I did, which is I went to F3 on the TI-89 and then chose integrate, and then the rest is like what I typed that's highlighted in black, and yeah, watch the video on the TI-89's integrate. Yeah, okay, cool. That's that, and the value is 101.325. Okay, and then part D, finalement, part D, what does that say? I don't know. Let's see. It says a lot. What is it? As water is pumped into the tank, blah, 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 blah. It's clearly a related rates question. And I have 7 examples on very different kinds of related rates problems. So check out those videos. But yeah, from this first part where they say when the height of the water is 5 feet, they tell us what dH dt is. Specifically, they tell us what dH dt is when t equals 5. And then in the rest of the question, and what they say is that it's equal to 0.26 feet per min, and it's positive because they say that it's increasing. But yeah, in the rest of the question, they're asking us for dV dt when t is equal to 5. So they're asking for dV dt when t is equal to 5. Now, we know that since they suggest that we use the model in part C, we know that V of H, so the volume as a function of H, from the model part C can be found by writing the integral from 0 to H of f of x dx, where f of x is equal to the model they gave us in part C, which is like e to the 0.2 x and then plus x, right? And because I'm using h here to ensure that, you know, my integral will be a function of h, that'll mean that I have to use a different variable here and of course there as a consequence, right? So instead of x, you could have used a t, but the fact that you had to use something not h was mandatory, right? Anyway, by the fundamental theorem of calculus, if we take the derivative of this on both sides, we'll find that dv dh, which is the derivative of the left side, dv dh, is going to equal, on the right side, we'll have to write f of h by the fundamental theorem of calculus, right? Okay, cool. But what we're after is dv dt, and I think we can easily gather that dv dt has to equal dv dh, which we have, right here, times dh dt, which we also have, and right here. And of course, we need to evaluate both dv/dh and dh dt at 5. So at t equals 5 is our interest at t equals 5. Okay. So if I can come up here, then what we have is dv/dh evaluated at 5 times dh dt evaluated at 5. But dv/dh is f of h, and so dv/dh evaluated at 5 will just mean f of 5, right? So we have f of 5, and again, this is dv/dh evaluated at 5, and then dv dt evaluated at 5, we're already told, is 0.26 feet per min. So 0.26 per min, right? Okay, cool. And so then what do we have here? We'll have, since this is measured in square feet, right? F of 5 is going to be a value that's measured in square feet. We have square feet times foot per min, which is going to be cubic feet, so feet cubed per min, right? And that should be sensible for a rate of change of volume, right? But otherwise, we just need to evaluate this, which is like figure out what f of 5 is and then multiply by 0.26. And I've done that in my calculator. And by the way, on the TI-89, I teach you like a really clever way to evaluate functions efficiently, like so, like how to find f of this is not the slide I wanted. So how to find f of 5 from your home screen of the TI-89. I show you how to do that. And so, you know, you should watch my TI-89 calculator videos. That's already out, so how to do that. So I'll link that video below this one, but I'm not going to teach you, like in this video, how I did it. Yeah, where do I put this? I don't know. Like, how about right here? But yeah, see what I did? Kind of, I'll teach it to you. What I did is like type the function f of x, so e to the 0.2x and then plus x as y1, and then I went to my home screen and I typed y1 of 5, which got me f of 5. I teach you this trick and more in a video I link below this on the TI-89. But yeah, this is it, and keep watching. Take care.